Hey guys, it is group 2 once again, and today we are at you with sequences. So think patterns and use your logic. They're like logic puzzles. It's fun. Alright, so an arithmetic sequence is basically an addition generator. So think back to when you were first learning multiplication. I'm not really sure what that you were taught, but for some people, their teacher may have explained that multiplication is like extended addition. So this is basically an arithmetic sequence. Another thing that it can be compared to is slope because it is a constant rate. Alright, so the number added to each term to make the sequence progress is called the common difference, and that is easily compared to the slope because it's the rate of change. For example, if we're going by fives, you see those patterns that you were taught, like how to count by threes or fives or even numbers. Yeah, those were arithmetic sequences. So 0, 5, 10, 15, and so on. And then 2, 4, 6, 8. Yeah, Alright, and a geometric sequence, it is basically a lot like the arithmetic sequence, but instead of addition, it uses multiplication, and it's not really compared to slope. Instead, it can be compared to exponents, but don't be confused, this little subscript right here, this is a multiplication sign, so the 2 is being multiplied by the 2, it isn't really exponents. So 2 times 2 is 4, 4 times 2 is 8, 16 times 2 is 36, and 32, and so on. And so, just to note, they're not exponents. Please remember that. It is extended multiplication. Alright, and now we're going to talk about the zeroth term. That's a really strange word. Alright, so a familiar term is coming up when I explain this. It is the starting point. Yay, so easy, right back to linear equations. Okay, so the starting point, it is like the y-intercept, it's where it starts, obviously. So when we're looking at sequences, there is always a first term. Like when we're reading a book, there's always a first word. Okay, so there it is, the sequence, and this is the first term that we read. So that first term is 1 because clearly it is the first thing that we read, and the zeroth term is the unseen term that comes right before it. So in order to get to it, you have to backtrack. If you can see this, the sequence is progressing by 4, and so in order to go back to get your zeroth term, you have to go back by 4. So 1 minus 4 is -3, and that will be your starting point. Alright, to sum up what we learned about arithmetic sequences, which is basically a sequence that progresses by addition, and it's similar to a rate of change. And a geometric sequence is a sequence that progresses by multiplication. It's similar to exponents. And the zeroth term is the unseen term that comes before the first term in a given sequence. Have a radical day, and we will see you next time. Yay!